Lesson 4.15, Linear Regression and Correlation. Today we are talking mostly about scatter plots, because when we talk about linear regression and correlation, we're really talking about what our calculator does when we use stat edit. So we're getting equation from essentially points. Now in the past, all the equations that we've gotten have been for perfect linear points. Take a look at these three graphs that we have below. We're going to talk a little bit about correlation. All right, so correlation is just a trend between two sets of data. All right, it can be positive, negative, or no correlation. And it's just like what you would imagine it is if you think about what we know about slope. So for these points, they're kind of tending to go up and right, which creates kind of a positive slope, right? So we would say that these dots have positive correlation. Using that same idea, take a look at the next one. We'd say that these dots have a negative correlation because as we continue to go further and further, we're decreasing in that negative slope. Finally, this last one, there's really no way to tell. I don't feel comfortable saying it's positive or negative. So in this case, we would just say that there is no correlation. It's not good enough to say positive or negative. So we say no correlation. Now, this is correlation, right? Again, one more time, it could be positive, negative, or we could say it has no correlation. What we do when we have these kinds of scatter plots is we'd find the linear regression line, the line of best fit, all right? This is what we call it most often. We call a line of best fit. Basically, we're saying that a line is not going to touch every single point exactly, but if we had to draw a line that fits the best for those points, what would it be? All right, it estimates the relationship between the points. So we use our calculator to find the equation of this line of best fit, and we already know how to do it. We're going to use stat edit, but we're going to do something a little bit extra this time. We want to have something show up called an R value. You guys go ahead and look down here at the right. You're asked for something called an R value, and you get it from stat edit, but only if you turn on your diagnostics. So follow the directions. We're going to go to the catalog in our calculator, which is down here above the number 0. So we're going to press second 0, and now our catalog is on. And we want to go all the way down to diagnostics on. All right. Go all the way down to diagnostics on. It's in alphabetical order, so it's just going to be another second or two. And here we go. All right. Oh no. Oh, that was not a good choice. Okay, hopefully that didn't happen to you guys. I'm going to go ahead. I'm going to try this. Go to diagnostics on here. And let's see. Go a little bit slower. Okay, there it is. So I'm going to press enter. Now you have to press enter again, right? You got to turn your diagnostics on. So now we're going to press, it should say done. All right. That's the only time you should have to do that today. Our diagnostics are on. All right, here we go. Let's go ahead and let's try and find the line of best fit for these points that were given in the example below. We're given these points -2, 6, 0, 4, 1, -1, and 4, -4. Now, just to kind of illustrate what's happening here, if you graph these points, -2, 6 is up here, 0, 4 is right here, 1, -1 is right here, and 4, -4 is right here. Do you kind of agree that I can't do a perfect line through these points? It's not perfectly linear, but we can kind of see that there's some kind of a negative correlation going on, right? There's kind of a linear relationship there. So we're going to use our calculator to find it. Go ahead and go to stat edit like we usually do, and we're going to type in these points. So we see -2 and 0 and 1 and 4. All right, on the right we've got 6 and 4 and -1 and -4. Now some of us have gotten into the habit of only typing in a couple of points. You have to type in all the points if we have a scatter plot. Okay, your calculator has to consider where every single point is if they're going to give you the best fit for all those points. So type in all the points. All right, next we're going to go to stat calc, right? Stat edit, stat calc. We want option 4, linreg. And now look what happens to my results this time that we haven't seen before. I get a and b, but then I get some other stuff, right? So the a for this equation is negative 0.36. The b value is 3.52. So we have an equation of y equals negative 0.36x plus 3.52. We would call this the line of best fits, right? This is the equation our calculator is giving us to just do the best line for those points. Now you don't have to know how to do this, but let me show you something on my calculator. If you go to y equals, if you go to stat plot, let's go ahead and let's turn this on. Again, you don't have to know how to do this. And in y equals, I'm going to put in this equation I just got. So negative 0.36 plus 3.52. Take a look at my graph. Oops, I forgot x, didn't I? Darn. All right, don't forget x. All right. Plus 3.52. All right, sorry about that. Right, that's what my calculator is telling me is going to be the line of best fit for these particular points. It's trying to get as close to every point as it can. So then we take a look at our R value, right? Look at my R value for this thing. Let me make sure it shows up again. So my R value is negative 0.302. I rounded a little bit. Negative 0.302. Is this line a good fit for the data? Well, we kind of saw it, didn't we? I mean, does that look like a good fit? It really does not look like a very good fit. It doesn't look like it fits those points very well. So we're going to say no. Okay? It's not a very good fit for the data. In fact, here's how we know if it's a good fit for the data. A good fit is close to 1 or negative 1. All right, if your R value is 1, this indicates a perfect line. So all the equations that we've done in the past would have an R value of 1 because they were perfectly linear. All right, but in our case, it's not great. So this is not a very good fit for the data, but it's a line of best fits, the best we got. All right, so let's do a couple of examples here. Let's look at example 2. We're supposed to write an equation for the line of best fits. So what do? Well, we have to put all these points in our calculator. So we have to take a second, and I would definitely go ahead and write down the points for this thing. All right, so we've got 540, and we've got 5, let's see here, that looks like about 65, and then we've got 1070, and we've got 1580. Oops, I forgot this one. This one is going to be 110. That one will be 15120. Then we're going to have 2120. And we're going to have 2140. A couple more. We've got 25150. And 25190. Then we have 3180. And finally, we've got 3200. Oof, that was a long list. But now we have to put that whole list in our calculator, which is going to be a little bit even more annoying. But we have to use all the points, you guys. Otherwise, our calculator won't understand. It won't have a good enough idea of where to put this line. So we got 5, 5, 10. I'm just going in the order that I wrote. 15. And 10 again and 15 again. And then I've got 2020 and 2525. And then I've got 3030. All right. So now we're going to go to the next Y column and we're going to type them in again. They have to go in the exact order that your X's were in. They have to line up. So 40, 65, 70, 80, 110, 120, and another 120, and then I've got 140, and I've got 150, and 190, yes, it's annoying, and 180, and finally we've got 200. Oh, darn. Look at what I did. I forgot to delete some, it looks like. Yeah, these ones didn't belong. Just delete those. All right. There we go. Looks like everything's lining up. Okay, I'm going to go to Stat Calc now, and we're going to want a linear regression for this information. Here we go. And all right. So here's my equation that I got. We got the slope is 5.47. I'm just going to round to 2 decimal places. And we got the y-intercept was 26.3 repeating. So my equation is just using those two, right? Y equals 5.47x plus 26.3 repeating. All right, that's my equation. So we definitely need to be able to find the equation. Now, what is the correlation coefficient? What is R? Well, R is this value down here. So we got 0.9. I'll round up to 4. Describe the correlation. Y'all, it is close to 1. So we're going to say a strong correlation, right? And it's positive, so I'm going to say strong positive correlation. That does make sense. Don't these points look pretty linear here? So we got a pretty good equation out of this thing. It's saying that this is pretty close to perfect, right? It's a positive correlation of 0.94. Again, the closer to 1, the better. Next, it says predict the time it would take for 18 people to line up in alphabetical order. Oh, we probably should realize that this is talking about the time in seconds for people to line up in order. All right, so we're going to use the information we just got to predict something, right? Let's see here. 18 people were our x values, so we're going to say y equals 5.47 times 18 plus 26.3 repeating, right? The equation that we just got to make a prediction. Here we go, 5.47 times 18 plus 26 points, I'll just do 33. So we get 124.79. So I'm going to say about 125 people. You know, this is what scatter plots are for, right? You plot actual information, and it's almost never perfect, but you use it to figure other things out, things that are similar, things that could happen. Last but not least, predict how many people could line up in 90 seconds. Well, 90 seconds was a y value, which means we're using my equation, but I'm saying 90 is y, so 5.47x plus 26.3 repeating. I don't know x, we got to solve for x. You guys are experts at solving for x. We're going to subtract 26.3 from each side. So I'm going to get 90 minus 26.33. And so now I've got 63.67 equals 5.47x. So last but not least, divide by 5.47. And we've got x equals, let's see here, divide by 5.47, 11.64. All right, how many people could line up in 96 seconds? Oh, darn it, look at my previous answer. I said 125 people. That was wrong. I was predicting the time, so this would be about 125 seconds. This time I'm predicting people. Well, I can't have 11.64 people, so I'm going to say about 12 people could line up in 90 seconds. I apologize for that mistake if I confused you. Okay? So here are our notes. The biggest things you could get out of today are to remember how to turn on your diagnostics, right? Here are your instructions to turn on your diagnostics. And to understand that the R value, the closer it is to 1, the more linear the points look. Okay? And you have to use all the points when you are finding an equation for a scatter plot.